Hi Marwa, this is the tutorial to show you how I did the in silico restriction assay for the 16s of Bellatoa. So uh, while I was doing the video, I just realized that I made a terrible mistake, and I will correct it now. So I will show you how you should do it, and actually the results that you have should be changed because I made a mess. I messed it up with the sense of the strands of the DNA. So in order to do that assay, you have to know first two things: the primers that you use and a reference sequence. So in this case, I have ready the primers here that you use for your PCR. So you use the 27F and the 517R. So this is the name of the primer and the sequence of the primer. You can obtain it from the literature, from the internet, from the protocol that you are using. So, but you have to have it in a text file editor to copy and paste on the Geneious or in any other sequence program that you are using to analyze your sequences. And also I have here the file for the 16S of Bellatoa leptiformis D402. So here's where I mess it up because it says here that is the minus stand. However, the IMG gave us you in the positive sense actually the sequence. So I will show you where I downloaded that sequence. I obtained it from the IMG from the JGI. So when you enter to your login, you can look for the keyword. So here I will put it Bellatoa and go. And it show you several ones. So the one that I choose was this one. And here you go down and you can go to the 16S RNA. So here, beep, you click on the number. It's charging. It will take a while. Come on, guy. You can do it. You can do it. Let's charge it again. No? Just, yes. So here you have, so it for that genome, for that strain, you have two sequences. I pick up just one. It's supposed to be, it has to be the same sequence actually. However, you have the coordinates from the location, from the sequencing, the negative one and a positive one. So that there is where I messed it up. So I just picked, I will pick the same that I have already there. And you can go here and you can go here. Sorry, here. So it's kind of tricky. You go and click here in the coordinates and it will show you the sequence. So here is the sequence. So you just copy and paste it and put it in a file, a text editor, as I show you here. So this is how it looks. You just it have this symbol here. That is the one that means that it's a FASTA file. And here you can put the information or keep the same information that you have from the web page. So that's the main importance of here is that you know exactly what is your sequence from, and the length and the position, etc. So okay, let's go then. So now that we have the file for the primers and for the sequence of the Bellatoa, we go to Geneious. And in Geneious, we will incorporate the sequence of the primers first. So for that, we will use these parts. In sequence, you go to new sequence, and we go to the file where we have our primers. So I put it here, primers, where are they? Primers, here. So here we will copy just the part of the nucleotides and we paste it here. So we know we will give the name of the primer 27F, and I will write that is a primer. This here appear because I already write it before when I was doing the first video. But basically you put here what it is. So it's a primer for 16 years of bacteria, and you can put bacteria here also. You can write everything that you want. And the important thing is here where you put that is a primer. So that is how the program knows that the sequence here is a primer, not a nucleotide sequence or anything else. So it's so important that you put here primer. So poop, and it's saved. There I have the other one. So now we will incorporate the other one. So we'll go to this one. We will copy this. There. So it's this one because this appear because I already write it, but the first time that you do it, you have to write it by yourself. It's a primer for bacteria, the same here and the same here. So, and it's a primer, really important to put there. So, we are done with the primer. So now our primers that you use for your PCR are incorporated in the Geneious. Now you can incorporate the 16S sequence through here, the same tool from new sequence, but then you have to write a lot, so I don't want to do that, and I can do it from here because it will recognize that it's nucleotide anyway. So I will import and file, import from file, and auto detect the format. So it will recognize the format because it's on a text editor. So the program will know automatically that that is a sequence that can read. So in desktop you have the Peyatoa leptiformis, the one that I copy and paste from the IMG, and here it is. So here it looks like there, but if you press here, it appears all the nucleotides really similar how you have it in your presentation. So here is where I messed it up because I read that it was the negative strand, that the negative strand goes from 3' to 5', and I did the reverse complementary thinking that I have to put it in the 5' to 3', but the program gave it already in the sense of the positive sense. So I don't have to do any change. That is why I messed it up during the ECODIM and I give you the wrong analysis. So now I will show you how to do it correctly. So now we have the sequence here, and the first thing that I will do is look for the position of the primer. So we can actually just work with the sequence that we are amplifying, because in the PCR you just have the fragment. You will not have a digestion for the entire 16S. You will just have the fragment that you're amplifying with your primer. So you go here to this primer tool and you can test with save primers because you already save it. So you can change here. So here you will have some primers that the program have by default, and the other one that we are comparated. So I did this 3 times. So, but all are the same. So we pick up the 27 and the 517. So it's done. And here you can put the maximum of mismatch. That means that the primer doesn't isn't it complementary 100%, so you are allowing to have some nucleotides that are not exactly the same in the same position. So you have it here. I said 5, but it could be less. Let's put 4. Because the primer is like 20 base pair, you cannot put a big number, otherwise it depends. So if you want to just look for the position, you can do that, like allowing a lot of these matches. But if you are looking if your primer will work to amplify some bacteria, and no, you cannot use too much mismatches. So then we go, and magically we have this. So here is where the 27 match, and in yellow is showing the mismatch. Here is the color references, so the primer binds in the forward one, and the reverse one is down here, and the mismatches is just one mismatch, and it's shown here, and it's one position here. So what we will do now is just remove all the sequence that we will not get in from the in the PCR. This is everything in silico because it's virtual, so we are assuming that our sequence will be really similar to the one from this Bellatoa, and the fragment will be the same side, etc. So we select this, just clicking, select, and then edit and delete. You are attempting to delete base. Yes, you need to turn on allow editing before making change. So allow editing, and then you see now we're starting from the primer. So this is another thing when you are working with sequences to do a phylogenetic analysis or to upload it in the database, you have to remove this primer too. But in this case, because our PCR will have for sure the primer incorporated, we have to include it in this case. But usually you remove also the primer. In this case, we don't. So now we are going here to the position of the reverse one and just do the same. And we edit and delete. And now we have this fragment that is for 514, so it's a little bigger than the one that I did the analysis before because I really messed it up. I will Skype you and I will explain you what I did. So now we are all set up. Here we can save it. And now to do the in silico restriction assay, we go here. So here you have several options. You can explore it by yourself. It's really user-friendly. That's where we were, like annotation tracks. So it's all the changes that we are doing to this sequence. And now we go to this one, to this little blue circle with an arrow, and it says restriction analysis. So you click on this box here, find restriction sites, and here you can look for the commonly used. And if you go here to advanced, you have a list of a lot of commercial restriction enzymes, and you can pick up all of them, none of them, or just some of them. So I remember that the one that you used was this one and this one. So we will ask for to look where it will cut. So now it results that it just one of the enzyme will cut here. So and you will not be able to distinguish this little fragment because the difference is too little here. So probably in your analysis you will not have any digestion pattern for the Bellatoa because it seems if it's your sequence from Bellatoa is really similar to this one, then it doesn't have that sequence in that region of the 16S. So I can print screen for you here, and I can send you this, so you can replace it from the one that you have in your presentation. If I do it here, there. So that is Marwa. I hope that is useful for you. See you.